Jaffna Hindu College. First term paper. Here, first question is a unit based on fundamentals of force. So here, fundamental of force, F is equal to ma. Unit of mass is kilogram. Unit of acceleration, ms minus 2. Altogether, kilogram ms minus 2. So answer would be kilogram ms minus 2. Then let's move to the next question. Which is not a unicellular organisms? Yeast, unicellular organisms. Amoeba, yeast is a fungi, unicellular organisms. So only bacteria and protozoa, all bacteria and all protozoa comes under the unicellular organisms. But other might be unicellular, multicellular organisms. So amoeba is a protozoa, even though it's a unicellular organism. Chlamydomonas is algae, unicellular organism. Mushroom is a fungus and multicellular part, reproductive part of the fungi is answer is mushroom. Mushroom is a multicellular organisms. Then move a group of elements in ascending order of mass in human body. Ascending orders mean increasing from minimum to maximum. So O, C, H and maximum O, we generally know that O is maximum. Then carbon, oxygen, carbon. Then hydrogen. Then nitrogen. This is the descending order. Now ascending order, they will write as a reverse of O, C, H, N. Then move question number 4. Glucose plus X equal maltose plus water. This is formation of disaccharide. What would be X? So we actually know that glucose, glucose plus glucose is equal maltose. Glucose plus fructose. Glucose plus fructose, sucrose. And glucose plus galactose. Lactose. Glucose plus galactose, it will give us lactose. So these are the 3 disaccharide, maltose, sucrose and lactose can be obtained by combining 2 monosaccharide. Here glucose plus glucose. Glucose plus glucose, maltose. This is the answers. Let's move to question number 5. The form in which carbohydrate is stored in the animal body is found. Stored in carbohydrate, stored in animal body. So carbohydrate can be stored in animal body as a glycogen in the liver and skeletal muscles. Liver and skeletal muscles. Nearly 100 gram of carbohydrate can be stored in the livers and nearly 300 gram carbohydrate can be stored in the muscles. So answer would be glycogen. Then move question number 6. What is a momentum? Momentum. Here you see M. So momentum and moment. There are significant difference between momentum and moment. Here momentum. Momentum is equal to mass into velocity. Here mass is given as a 1250 kg, 1250 kg mass. Then velocity is given as a 4 ms minus 1. So we have to multiply mass into velocity in order to find out the momentum. Mass into velocity. Velocity is 4 ms minus 1. Then move the next question. Consider the following statement related to frictional force. So actually you know that the frictional force acts on the conduct surfaces and opposed to the motions. So when we go to the answers, always found against the applied force. Frictional force found against the applied force. Yes, always it will be against the force, against the direction of motions. But when we go to the statement 3, when a force is applied to an object on horizontal surfaces, only a frictional force is applied. So what about the inclined plane? Here also there is a frictional force. No, it works not only the horizontal, inclined and vertical, so everywhere. So because of that, this answer is wrong. So we can go to A and B. So which is first answer is correct answer. Let's move the question number 8. Here element symbolized as a X 2713. So answer question 8 and 9 with valency. Here valency. Actually we know that valency. There are 8 groups in periodic table. How many groups? 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. So when we talk about the valency, here valency will be 1 because it has 1 electron in the last orbit. 1 electron in the last orbit. So it will lose this 1 orbit and it will get a strong electronic configuration like group 8. If it is the group 2 element, it will has 2 electron in the last orbit, so that it is organized in the group 2. So it will lose these 2 electrons and it will get the strong electronic configuration, so that this valence is 2. If we go to the group 3, last orbit has 3 electrons. So it will lose these 3 electrons and it will get the strong electronic configurations of these atoms. So here valence is 3 because it's lost 3 electrons. If you take these groups, group 4, so it will lose or it will gain 8. It will lose 4 or it will get 4 electrons in order to gain the strong electronic configuration. So its valence is 4. And group 5, there are 5 electrons in the last orbit. So in order to get the strong electronic configuration, there are 2 possibilities. It has to lose 5 electrons and get this electronic configuration, strong electron. And it will get 1, 2, 3 electron and get strong electronic configuration. So which is possibly easy. losing 4 electron or getting 3 electrons. So that it will get 3 electron in order to get a stable electronic configuration. The group 6 electrons present in the last orbit. So it will get 2 electron and get a stable electronic configuration. So group 7 electron in the last orbit. So it will easily get 1 electron and get stable electronic configuration. So here, so group 8 already they have stable electronic configuration, so that the valence is 0. Group 8 valence is 0 because they already have strong stable electronic configuration. So you can have 1, 2, 3, 4 valencies. Again 3, 2, 1. So it is, you have to remember the valence. 1, 2, 3, 4. Then 3, 2 1s. No positive, no negative value for valence. Then let's go to the question number. Here, how many electrons are there? Here, atomic number is 13. 13 means number of proton 13 is like number of electron 13. So we can write the electronic configuration as a 2, 8, 3. 2 plus 8, 10. 10 plus 3, 13. So this is the electronic configuration of X atoms. So then we can find out how many electron in the last orbit? 3. So if it is last orbit 3, it will come here. So group 3, and what is the valence for group 3? Valence is 3. Valence is 3. So here valence is 3. Then move question number 9. The period and group of element respectively. The group, the period and group of element X respectively. So if you go to the electronic configuration of this element 283. So we can find out the group number, electron presence in the last orbit. This is the group number. Group number should be written in the Roman number. Group number should be written in the Roman number. Then how many periods? So period can be counted how many orbit or how many cells here. How many cells are there? This is the first orbit. This is the second orbit. This is the third orbit. Or 3 orbits are there. So this element come under the group period 3. Period 3 and group 3. Period 3 and group 3. This would be the answer. And who was the scientist revised the published Rutherford planetary model? Who was the scientist revised and published Rutherford planetary model? So here Niels Bohr. Niels Bohr revised the Rutherford's planetary by adding what? How do we call? We call it's a energy level. So energy level is introduced by Niels Bohr. Energy level. So that's all. We can continue in next video clip.